At the bottom of the moon's far side, there's something buried that shouldn't exist. NASA's GRAIL satellites detected it in 2019. A mass the size of 5 Hawaiian archipelagos, buried hundreds of kilometers deep beneath the largest impact basin in the solar system. So dense it pulls the basin floor a full kilometer lower than it should be. Get this, if the models are wrong about what's down there, they're also wrong about how the moon formed, and about what may have happened here on Earth at the same time. Nobody has gotten close enough to know. Until 2028. 3 questions geophysicists still can't close. First, what exactly is the anomaly under the South Pole-Aitken Basin? And why does its size break every available model? Second, what are the 2 hypotheses? And which one does the most recent data favor without confirming? And the question that connects everything, if that anomaly is what nobody expects, what does that say about what else is buried in the side of the moon we never see? Stay until the end. Around 5 minutes in, I'm going to ask you something specific, and what you answer is going to be part of a real conversation. Let's start with scale, because without understanding it, the anomaly has no weight. The South Pole-Aitken Basin is 2,500 kilometers across, 8 kilometers deep. Placed over Europe, it would stretch from Lisbon to Moscow. From the center to the edge, you'd drive for more than a day without stopping. It's the largest and oldest known impact basin in the inner solar system, formed roughly 4.3 billion years ago, just 200 million years after the birth of the solar system itself. The impact was so violent it excavated all the way into the lunar mantle, the layer beneath the crust that normally never gets exposed. Minerals that had been sitting hundreds of kilometers down for billions of years ended up on the surface. The interior of the moon was ripped open, and in that moment of geological chaos, something got trapped underneath, something that's still there. And here's where it gets interesting, because the mass they found isn't small. In 2019, Peter James's team at Baylor College of Medicine analyzed data from NASA's GRAIL mission, 2 satellites that spent years mapping the moon's gravitational variations to millimeter precision. When they ran the numbers on the South Pole-Aitken Basin, they found a gravitational signature that shouldn't exist. Beneath the basin floor, hundreds of kilometers deep in the mantle, there's an anomalously dense mass concentration, equivalent in volume to 5 times the Hawaiian archipelago, but buried, compressed, invisible from the surface. And that mass is large enough to pull the basin floor approximately 1 kilometer lower than it would sit without it. 1 kilometer. Caused by something no instrument has ever seen directly. But here's where the real problem starts, because it's not just that the mass exists, it's that it doesn't fit either of the 2 available explanations. The real problem wasn't detecting the anomaly. It was that the models built to explain it can't reproduce it perfectly. Geophysicists have 2 hypotheses. The first is the most dramatic, and the one with the most intuitive support. Hypothesis 1. It's the core of the asteroid that formed the basin. When a massive object strikes a rocky body at tens of kilometers per second, part of the projectile vaporizes, part bounces off. But at certain angles and velocities, the metallic core of the projectile can sink into the mantle of the target body without escaping. If the asteroid that created the South Pole-Aitken Basin had a sufficiently massive iron-nickel core, which is likely given the crater's size, that core could still be down there, buried, in the exact spot where it landed 4.3 billion years ago. If that's correct, the moon's largest crater has been carrying the heart of an asteroid inside it since before life existed on Earth. An object that traveled through the solar system for millions of years, hit the moon, and never came back out. Hypothesis 2. It's a concentration of dense mantle oxides. During the cooling of the lunar magma ocean, the first few 100 million years when the moon was molten rock, the heaviest elements sank toward the center. That process wasn't uniform. Concentrations of titanium oxides and dense elements may have accumulated in specific mantle regions, in ways that cooling models don't fully predict. The SPA impact may have disturbed that distribution, concentrating dense material in that specific zone during the chaos of the collision. If that's correct, the anomaly is an accident of internal physics, unsettling in shape, but explainable without any foreign core. Now, here's the data point geophysicists mention most carefully. The spatial distribution of the anomaly doesn't match exactly what a spherical asteroid core would produce. It also doesn't match exactly what a naturally distributed oxide concentration would look like. It's compatible with both hypotheses, but neither one reproduces it perfectly. There is something down there that no current model fully captures. Think about that for a second. We have $2 billion satellite missions worth of gravity data, and the best answer science has is probably one of these two things, or maybe both, and we can't tell which from orbit. Now I need to ask you something. You've been processing this for about 5 minutes. The scale of the basin, the GRAIL data, the two hypotheses, the anomaly that doesn't fit either one cleanly. Go to the comments right now, not at the end, now, and write one word: asteroid. If you think it's the projectile core that got trapped 4.3 billion years ago. Mantle. If you think it's an internal concentration of dense material. One word. When you finish the video, I'll tell you which one the most recent data favors, and I'll reply to every comment personally. You can pause and write it now. I'll be here. If you've made it this far, hit like. It helps more people find this information. Here's what the most recent data is pointing toward, and what's still not in any official press release. The Chang'e 4 mission, which landed in the Von Karman crater inside the South Pole-Aitken Basin in January 2019, carried a lunar penetrating radar called LPR. That instrument probed the subsurface during the first meters of U-22's traverse and found layers of material with distinct properties stacked in sequence. That's consistent with the Mantle hypothesis, material of different densities deposited in layers during cooling. But U-22's radar can only see the first few meters below the surface. The anomaly is hundreds of kilometers deep. It's like trying to figure out what's at Earth's core by measuring the soil in your backyard. In 2024, Chang'e 6 samples, the first ever returned from the far side, confirmed olivine and pyroxene minerals that only form at great depth. That proves the SPA impact excavated into the mantle, that the moon's interior was exposed. But it doesn't resolve what got trapped down there. And there's something else. The most recent computational models attempting to reproduce the anomaly suggest the most likely explanation isn't just one of the two hypotheses. It's a combination. Part metallic projectile core, plus mantle material disturbed and concentrated by the impact. Both things at once. Turns out, if that's correct, what lies under the South Pole-Aitken Basin is the result of the most violent event in the history of the inner solar system. An asteroid whose core got trapped, mixed with disturbed lunar mantle, forming something that didn't exist before the impact and doesn't exist anywhere else on the moon. Unique, unrepeatable, and still unnamed because nobody has seen it directly. The only way to resolve it is with high-resolution seismometers placed on the basin floor, instruments that record moonquakes and analyze how seismic waves change as they pass through materials of different density, exactly how geologists study Earth's interior. Artemis IV plans to land at the lunar South Pole in 2028. The astronauts will carry next-generation seismometers, the first high-frequency seismic instruments ever to operate in the Anomaly region. For the first time in history, we'll have data that can distinguish between an asteroid core and a mantle concentration hundreds of kilometers down. If those readings show a dense, concentrated spherical disturbance, the asteroid core. If they show distributed layers of material, the mantle concentration. And if they show something that fits neither, then the far side has a third secret we don't yet know how to ask about. The far side of the moon isn't just the hemisphere we never see. It's where the most violent event in the history of the inner solar system happened. An impact that ripped the moon open. That exposed the interior of a world. That left something buried that 4 billion years later still has no definitive explanation. And if the models are wrong about what's down there, they're also wrong about the exact history of the moon's formation, about how the inner solar system evolved in its first millions of years, about what was happening here, on Earth, in that same period. The answer is buried, waiting, and in 2028 for the first time, we'll have the instruments to hear it. If you wrote asteroid or mantle in the comments, stay. Over the next few days, I'll reply to everyone with what the most recent models favor. This isn't an exercise. It's a real conversation about something science hasn't closed yet. What do you think is buried under the largest impact basin in the solar system? Tell me below. And if this video changed how you see the moon tonight, subscribe. Next week, the seismometers Artemis IV will leave at the South Pole, and what they might hear if the anomaly is what nobody expects.